Hello everyone, you are in Endurance Laser Lab. Today I am going to guide you and explain how to create slices if you want to do laser cut and you have a 3D model that you created in 3D Max. So let's start. First of all, we need to run 3D Max. Okay, set up parameters, customize, unit setup, metric. Well, I like millimeters. We're in Russia. We don't like inches, just for simplicity. NASA guys also use millimeters and metric system. Now let's import our model. Okay, somewhere we had a Christmas tree. Yeah, New Year's passed. And we want to build a new Christmas tree for next year. Okay, so let's set up quick weld. Then our model loaded faster. Okay, now you can see it here. Okay, looks nice. Okay, let's check for interactions. Right, so we don't need intersections, sorry, of surfaces. So we need that surfaces would not intersect each other. So we need to remove it. Let's say eliminate. Okay, now we need to detach the border of the Christmas tree. Let's hide everything but the body. Okay, the model is not locked now. Yeah, we can see it here, and yeah, probably to say closed. I don't know. So now we can join. Okay. So let's compound object Boolean. Select union and click start picking. And select the body once again. No intersections now, right? So the model is clear, neither at the top. So select start picking to finish the object. Let's adjust the size. So let's make it like 10 centimeters. So we need a ruler. Okay, and let's make it more like 10 centimeters high. It's like for Americans, it's like 4 inch. It's not a big one, but we want to show you how to make it for DIY machine. So you'll be able to use our DIY machine with a size 8 on 8 inch. Okay, let's set 0 on Z-axis. Now scaling is possible. Now we can actually decrease the size. We scale it smaller. Make sure that will be its size and 10 centimeters, 4 inch. Couple millimeters won't make any difference. So we don't need this box anymore, so we scaled it back. Remains to cut. Use a grid blending. Okay, let's go to magnet. Okay, home grid tab. Okay, select grid equal to our desired size. Make sure that the grid points here. Okay, create all shapes. Put it in the center. Okay, so we put it here and activated binding. Okay, and now let's cut it into slices. So we'll do 1 centimeter, so cross sections. Okay, shift by 1 square. So now we'll cut every single slice. So as you can see, this third tree will have like 20 slices, something like that. Okay, so we cut every single square, so it's like maybe half centimeter. Okay, so we did that. Right, so we have different slices of our third tree. So we don't no longer need any don't need a 3D model. We already cut it into slices. Right, we're about to delete it as soon as we already have these slices shapes. Okay, let's move it here and remove it. Okay, now you have slices that we need to adjust a little bit. Check the result and thickness, the layers with the extruder modifier. Okay, right now we have it. We can set extrusion. Okay, we don't need small objects like this. So let's remove tiny details, tiny slices. We don't need them because it looks pretty good without them. I mean, you can leave them, but in fact, in this tutorial, we just want to make it simpler, and then we just delete slice after not slice, but part from a slice, one after another. Okay. I think that half of our job is done. I don't know if you have the saying, well begun is half done. I think we already did half of the process. So now I have slices, right? As you can see, look pretty good. We are about to ready to put them into one plate. Okay, let's make the same color because fir tree is green, and prepare the outlines for the export. Select all of the layers and delete the extruder modifier. Right, okay, you can see different layers. Turn off the grid with G button. Pull apart the outlines to avoid overlapping. Okay, so we want to make sure that every single slice will not overlap with the previous one. Oh, yeah, I think I messed up. I know. Okay, we're all ready. Okay, let's select everyone, but without the last one. Right. Almost done. Yeah. Okay, we did it. You can see them in all the align the outlines in one plane. Right click the shift tool. Make the y coordinate equal to 0. It's very important. Okay. And you see that they're all on 0, right? And now we can put them together. So now distribute the outlines more compact way. So let's rotate it 180 degrees, and let's move it up. Just want to save our material, so we want to put it onto one, let's say, square plate. Let's rotate this part as well and put it here, and the same exercise we'll do with this piece. Okay, so we moved it here, but you see that we need to avoid any intersections, so we'll move it a little bit to the left to make sure that we have enough space between these two parts. Let's move it closer here, and also closer here. Okay, now I like it. Yeah, and you see it here, so we need to split them a little bit, right? Create a rectangle around the outline, so we want to make a certain size, so we need to restore the real outline size after importing, because we need to make sure that we know the size of our plate. So we have a, let's say, 160 millimeters. On 160 it's like closer to 6 inch, so that you'll be able to do this laser cutting on our DIY machine. Export possible, export. Specify a directory. Click save. Save in version 2000, not really necessary, but latest version are also good to be imported. Okay, to generate G-code we use Inkscape and GT Photonics, so here are links. You may go and check it out. Also you may download Inkscape and plug in from our website endurancelasers.com and just go to the bottom and find download center. Doesn't support DXF actually, the Inkscape, so we need a special converter. That's why we go to a website dxfconverted.org and we take our file, right, and we want to save it as SVG, right? So now it's processing. The result will be fast enough. So okay, now we have SVG file. Yeah, just for simplicity, you may use other converters as you wish, but we like this one, and this solution works pretty good. Set the measurement, file document properties, choose millimeters, import the outlines to Inkscape, select the SVG file, okay, the outlines are not seen, visible. Let's select change thickness. Now bring them to real size, because you remember we have 160 millimeters, almost 6 inch for American European guys. I think American and British mostly. Europeans, they use millimeters and metric system. Okay, so we are all set. So we need to combine the corners just to make sure that we will match the sizes, and we'll put it all together. Okay, now you can see. Combine the rectangles. Now we're all set. The outlines are set by 1. Ungroup the imported outlines, because we need to remove these lines from, the rectangle. We don't need it anymore. Let's ungroup it. We use Russian version, so delete everything except our third tree. Okay. Now we're all set. Okay, we're almost done. We have about a couple minutes left. So we need to go to generate the G-code. Go to generate G-code. Use GT Photonics. We can change different parameters: laser speed, laser power, passes. For these, let's say 10 passes would be enough. If you use not 8-watt laser, for 8-watt laser you can cut with 1 pass 4mm of plywood or wood. But to make sure you do experiments before. So when you know exactly before parameters, you can do it before. You can do it in advance just to check it out. Because you don't want to have burned outlines, and yeah, let's do this. Okay, click apply. Takes some time, even on a faster computer. Generating G-code probably would be like 20, maybe 30,000 lines, because they are also repeats. So basically, would be like 5,000 probably, and when you multiply on 10. Oh, maybe 20,000. So we are almost done. You can see a final G-code. Now you can use it and run on different solutions, on like Penbox, CNCC, LaserX. That's it. So I hope that you like this video. Please share it with your friends, and you may put our likes. They encourage they encourage Endurance team to make more videos and guidance. And have a nice laser cutting. Hope that you like it with our lasers. And have a good day. Bye bye.